Hi everyone, welcome back. Continuing with the second method in the analytical methods to find out the principal planes. We look at some numerical problems. Problem 3.5 from the textbook. The tensile stresses at a point across two mutually perpendicular planes are 120 Newton per mm squared and 60 Newton per mm squared. Determine the normal, tangential, and resultant stresses on a plane at 30 degrees to the axis of the minor stress. Now let us first get to understand our diagram, and then we will look at what is given, and then we'll go into the process of solving. So you have a member where you have got stresses on all the surfaces, right? So this is given as sigma 1, which is equal to 120 Newton per mm squared, and this is sigma 1 as well. And we have stresses on this side given as sigma 2, which is equal to 60 Newton per mm squared. Yeah, this is sigma 2 as well. Now, we know that the axis of major and minor stress from these two, sigma 1 and sigma 2, we can understand that 120 is greater. So that will be the axis of major stress. So let me pick up a different color. So this is your axis of major stress. And then obviously you have got this, which is your axis minor stress. Now we have a plane which is at an angle of 30 degrees from the axis of minor stress. This is what is given. Now let us start recording what information is given and what information we need to find out. So the major principal stress is given, sigma 1 is equal to 120 Newton per mm squared. Minor stress is given, sigma 2 is 60 Newton per mm squared. And the angle of oblique plane with the axis of minor principal stress is given, theta is given as 30 degrees. All right, and now it is asking us to find out the normal stress. Normal stress is sigma n. You've got two mutually perpendicular planes, and obviously mutually perpendicular stresses are on the planes. And under this condition, the formula is sigma n is equal to sigma 1 plus sigma 2 by 2 plus sigma 1 minus sigma 2 by 2 cos 2 theta. That's a direct substitution here. 120 plus 60 by 2 plus 120 minus 60 by 2 cos 2 into 30. Yep. So 120 plus 60 is 180 by 2 plus 120 minus 60 is 60 by 2 cos 60. Now resolving further, we get 90 plus 30 cos 60. 90 plus 30 cos 60 is 1 by 2. So you get 90 plus 15, 105. This is sigma n, Newton per mm squared. Now he's asking us to also find the tangential stress. Tangential stress is sigma t. We have a formula where sigma 1 minus sigma 2 by 2 into sine 2 theta. Substituting, you get 120 minus 60 by 2 into sine 2 times 30. 120 minus 60 is 60 by 2, sine 60. So this is 30, sine 60 is 0.866. So your answer will be 25.98 Newton per mm squared, sigma t. All right, so you've got your two answers. Now he's also asking you to find out the resultant. We looked at the formula for the resultant, which is nothing but root of sigma n square plus sigma t square. So sigma n square is 105 square. I have to be careful with my zeros. They look more like 6, but I'm sure you guys won't get confused. And sigma t is 25.98 squared. Yep. Root of 11025 plus 25 squared is 674.96. And then solving this, you get 108.16 Newton per mm squared. This is sigma r. That's your first problem.